recording as well. طيب, we are going to continue covering now module 17. Few slides left. Now, what we have in this table? Usually, for a Cisco iOS command line interface, show command is very important command for the troubleshooting. So as you will see on the first meeting, when we start CCNA2, we'll talk about the show, many cases, troubleshooting. We will use it to verify what usually the main goal is to verifies the current configuration, the interface status, layer 3 information on the interface, list of hosts. When we talk about the route, the IP route. So mainly this command or show command followed by, let me say, a keyword, display relevant information about the configuration, about the operation of the devices. So it's mainly used by the network technicians for viewing information files, configuration files, checking the status of the device interface, the process, verifying of the device operate or the operational status of any device, the status of the nearly every process or function of the router also can be shown or viewed by using the show command. So we have summarized some of the show commands, and the description of each of command can be used when we troubleshoot our network according to this table. If we use show running config, this command is used to verify the current configuration and setting. We need to review the overall configuration. So we can use show running config commands at this case at the privilege exit mode, by the way. Show interfaces in order to verify the interface status. Display any error message or CRC problems, as we will see in the coming class, inshallah. Show IP interfaces, verifies layer 3 information of the interface or of an interface. Show ARP, you know ARP, address resolution protocol. So verify a list of known hosts on the Ethernet LAN. Show protocols, verify which protocol are operational, we can run, we can stop any running protocol. Show version, finally, verifies the memory interfaces license of devices. Now we need to know in general what's the main task. We are going to have a full details about the show troubleshooting commands, inshallah, this week in our next class. Also, we have an important command called show CDB neighbors command. CDB stands for Cisco Discovery Protocol. So the CDB or Cisco Discovery Protocol is a Cisco protocol, Cisco proprietary protocol running at data link layer. So because it's running at data link layer, it allows two devices. For example, we have routers. These routers support different network layers. So two different devices supporting different network layers, by using this command, they can learn about each other. Even if layer 3 connectivity has not been established. I'm talking about layer 3 here, the IP. So how it's work or how it's running. Once the device is booted, we are talking about a router, for example. Cisco Discovery Protocol starts by default. So it will automatically discover any neighboring Cisco devices running the CDB as well, regardless of what we have or which layer protocol is used or run. So CDB exchanges here hardware and software devices information with only the directly connected neighbors. So two routers can learn about each other in this case by using CDB protocol or CDB neighbors commands. So what are the information provided? CDB provides the information or the following information about each neighbor device. What we can get: the device identifiers, the configuration host name of a switch, router, or any other device, address list up to one network layer address for each protocol supported, port identifiers, the name of the local and remote port in the form of the ASCII character. For example, fast Ethernet 01. As we will see here, we will talk about this output now. Capabilities list, whether a specific device is layer 2 or layer 3 switch. And finally, the hardware platform of the device. So for example, here we are running at R3, router 3, the command show CDB neighbors details, or show CDB neighbors only without details. So what we have here, we have some codes: R router, S switch, D remote, for example. What else? R repeater, B phone, and so on. Source route bridge. So what we have here, it's showing that R3 is connected with switch 3 through its local interface Giga Ethernet 001, and this interface is connected to a switch. The switch platform is Catalyst 2960 on port fast 05. On a fast Ethernet 05. So each device can learn about the neighbor directly connected device by using Cisco Discovery Protocol, which by default started once the device is booted up. Now, what about show IP interface command? One of the most frequently used command is show IP interface. As you see, we use it at the privilege exec mode. So the commands provide more abbreviated output than show IP interface commands. Simply, it's provide a summary of a key information for all network interfaces or routers or on a switch. So for example, here on router 1, we have run the command show IP interface brief. So what we have: interface name, IP address, is it operate or not, status, the protocol. So gigabit Ethernet 000 with its IP, it's operate or active, configured manually, status is up, so the hardware is running without any problem, the protocol is up as well. We have another one with its IP, operate without a problem, manual configuration, status is up, and the protocol is up. What about the other interfaces? As you see, all of them down. Gigabit Ethernet 0 is unassigned and it's by the administrative shut down or switched off down. Can we run show IP interface brief command on the switch? Yes, we'll get the same details. For example, here, virtual LAN 1 assigned an IP to manage the switch remotely. We are talking about a virtual here interface with an IP address, status is up, and the protocol is up. So we can review or preview all the interfaces, summary information by using show IP interface brief command at the privilege exec mode. Now, we done with the network, we done with the configuration, we done with the commands. Let us talk about the main steps to troubleshoot a network. Any network will have a problem. It can be a very simple or it can be a very complex problem. And usually the problems result from a hardware, software, connectivity issue. So technical teams or technicians must be able to analyze the problem, determine the cause of the error or the problem, and resolve it as well. So find the problem, try to solve the problem, check if it's solved or not. So what we are doing here, we are going through a steps of a process called troubleshooting. So in general, we can show that we have 6 main steps can be followed in order to troubleshoot the network or to discover any error in our network. Step 1, as a technical or a technician, you need to identify the problem. So the first step of the troubleshooting process is to identify the problem. We can use the tools in these steps. A conversation with any external users will provide a very good information here in order to lead us to identify the problem correctly. Step 2, we need to establish a theory of probable causes. We need to have a list of the source or the causes of this error. So after the problem is identified, we need to try to list down, for example, the causes, the probable causes of the problem. So this step usually leads to have more than a few probable causes of the problem. It may be we have, for example, we'll assume that we have 3 main causes to this problem. So we need to test a theory 1, theory 3, and next step. So identify the problem, step 1, list down or provide the probable causes of the problem is a list, step 2. Step 3, we need to test the theory to determine the cause. Based on the probable causes identified in the previous step before, we need to test the theories. Is this the cause of the problem or not? So which one is the main source of the problem? So usually technician may apply a quick fix solution to test if the problem is solved or not. If the quick test does solve the problem, so the problem is fixed. If it does not solve the problem, we need to do more research further to know exactly where is the cause of the problem. Once we know the cause, now we need to do or to set down a plan how this problem will be solved and how the solution will be implemented as well. So after you have determined the exact cause of the problem, you need to set down a plan of action to resolve the problem and the implementation or the solution implementation as well. Step 5, we need to verify that the solution we have implemented solves the question, solves the problem correctly, and we need to implement some preventive measures. We need to avoid to have the same cause, same error in the future. So after you have corrected the problem, verify full functionality. If applicable, implement a preventive measures. Finally, whatever you have done should be documented. Document the findings, the results, the action were taken, and the outcomes achieved. So in the final step of the troubleshooting, document your findings, action, and outcome. This is very important for a future reference. Now, what's the type of the question might comes based on this table? If you have checked the Academy, you will see they will give you a scenario for troubleshooting, and they will ask you to identify which one of these steps you are at now based on this scenario. Usually a troubleshooting scenario and a question about that scenario based on this basic troubleshooting approach. Now, in case we have any problem, we have 2 types of actions can be taken: resolve or escalate. So what's the difference between them? Now, in some cases or in some situations, it may not be possible to resolve the problem immediately. For example, after we diagnose the overall network causes, network technician come out with a conclusion: router should be replaced. So you do not have the right actually to replace the router. Even you do not have a router in your stock, for example, so you need to purchase a new one and later on install it or replace it with a router that has the main error source. So what we will do in this case, we need to escalate, rise it up in the other way as a problem. So the problem should be escalated when it's required a manager decision. Some specific expertise, for example, or network access level unavailable to troubleshooting technician. Sometimes the problem I would like to investigate, I do not have an access privilege to this level. So we need to escalate it, in this case, to the higher management level. So in the example of the router, for example, I will rise up my report to my technical manager. Router should be replaced. The top manager will approve the solution proposal. It will rise it up to the finance department. Finance department, for example, will approve the order. They will order a router, a new router will be ordered. Now we can install or replace the router. So we should follow what? A policy. And the company policy should be clearly state when and how technicians should escalate the problem and what's the procedure should be followed in case the problem will be escalated to upper level or higher technician level. One more command also, it's very useful and helpful, the debug command. So debug command allows the administrator to display the operating system process. What happened exactly? What's the messages sent and received? For example, we can debug all the steps of the ping command by using the debug command. So it allows or provide the administrator the ability to display OS process, protocols, mechanism, even messages in real-time situation for the analysis. All the debug commands enter at the privileged exec mode. This one is very important. It might be a question. Cisco IOS allow for narrowing the output of debug to include only relevant features or sub-features. Now, how we can apply this, we are going to take many examples about how we can focus on a specific output. This is what we are seeing here by using the show command, inshallah, in this Thursday. So use debug commands only to troubleshoot a specific problem. For example, in order to list a brief description about the debugging commands option, how we can know what are the options can be used along with the debug commands. At the privilege mode, we can run debug followed by the question mark. So in this case, all the options available with the debug commands can be listed. Now, can we stop specific debugging features? Yes. No. Debug IB, ICMB, for example. Debug IB, ICMB. Can we stop all the debugging process? Yes, we can use undebug all as well. So either we can use no in front of debug commands and then what we want to stop or turn it off, or we can use undebug form of commands in the privileged exec mode. What if you want to turn off all the activate debug commands at once in a single command line? we can use undebug followed by all. Be careful when you use the debug command as well. Sometimes debug command will generate substantial amount of output. Let me say larger amount of output. So this amount of output will use a large portion of the system resources. It will lead to the router will get displaying the debug messages that is would not have enough processing power to perform its network function, or even listen to our commands to turn off the debugging. What's the debugging output I'm talking about? These, for example, here we are debugging the ICMP, ICMP, the ping echo request and echo reply. As you see, we have a full details debugging process. So sometimes it will lead to make the router busy. So you need to be careful when we use it. Now, how we can run the debug? As you see here, if you can see debug ICMP, how we can turn off this process, undebug, or sorry, no debug ICMP. Now, debug commands and certain other iOS message output is not automatically displayed in remote connection. In remote connection, you will not see all the information of the debug messages. This is because the log messages are prevented from being displayed on the virtual terminal line. So how we can display the messages on a terminal in virtual console? Now, here we are talking about the case you would like to debug your router remotely. We have a remote connection, telnet connection or SSH connection. Usually, messages log file is blocked or prevented. So what we can do to display the log messages of the debug process remotely? We can use the command terminal monitor. As you see here, before we start debugging the ICMP, what we have entered at the privilege mode, terminal monitor commands. After that, we run the command ping 10.1.1.1. We have seen here that 5 sending ICMP replied correctly according to the indicators, exclamation mark, and we have sent 5 messages correctly, 5 received with a rounded trip. Now what we have here, the debugging messages details. So how we can view messages remotely in case we have a remote connection with a switch or the router, we should run terminal monitor commands before. Also, as you see here in this example, we have a switch off the ICMP debug by using no debug ICMP commands. Now, finally, what we have here, we have 4 or 5 troubleshooting scenarios. Now, 1 second, please. So, one of the main problem or source of a problem is the duplex mismatch issues. What's the duplex mismatch? Now we know that ports or Ethernet can operate either have duplex or full duplex. So duplex mismatch problem occurs when one of the sites operate as a full duplex while the other one will operate as a half duplex. So connecting Ethernet interfaces must operate in the same duplex mode, full or half duplex, for the best communication performance and to avoid any latency or a collision in this case as well. So Ethernet auto-negotiation features We are talking about the MDIX here. Facilitates configuration, minimize the problem, and maximize the link performance between the two interconnected Ethernet links. The connected devices must first announce their supported capabilities and then choose the highest performance mode supported by both ends, which means two Ethernet connected. Both of them enable auto-negotiate. They will negotiate about the speed. I will operate by using full duplex. I will operate on the full duplex mode. We have agreed the duplex mode. Now they can start operate using the full duplex mode. Now, if one of the two devices operating in full duplex and the other device operate in half duplex. So what we have here, duplex mismatch problem. So while the data communication will occur through the link with a duplex mismatch, you will notice that the link performance will be very poor, or the data that will be received at the destination is a corrupted data because of the collision. Why? Because the full duplex can send and receive at the same time, where half duplex can only send or receive at a time. So duplex mismatch are typically caused by the misconfiguration of the interfaces, or in some situation, which rarely may occur, we have failed auto negotiation process. So duplex mismatches may be difficult to troubleshoot as the communication between the devices is still active, still occurs. Another problem or another source causing problems, the IP address. We need to see if we have configured our interface correctly or not. Is it active or not? Is it up or not? So two common causes of incorrect IPv4 assignment, or two common, causes of incorrect IPv4 assignment are manual mistake or DHCP related issue. Now we know that in order to assign an IPv4 to any device, it can be configured manually, or it can be assigned or allocated through the DHCP. So the two common causes of the IP problem here, incorrectly manually configure the IP or DHCP configuration issue or a problem. So network administrators usually have to manually assign IP address to a permanent intermediary devices such as servers, routers. So in case any mistake is made during we are assigning an IP address manually to a server or a router, for example, then we have a communication issue problem, which is very likely to be the main source of the problem in this scenario. So in order to verify the configuration, we can use show IP interface commands, or we can use show IP interface brief commands to verify what's the IP address that assigned to each interface. So what we have here at router 1, we have issued the command show IP interface brief. What we have here, we have a list of the interfaces, IP assigned, status of each interface as well, which is very helpful when we are troubleshooting a network and we have an IP address issue. Also, in devices, for example, it might have an IP address problem, not only the servers or the routers, which usually assign the static IP address, not dynamic. Now, in Windows operating system based machine, when any device cannot contact the dynamic host configuration protocol server correctly, Windows as an operating system will assign an address belonging to this range or domain. 169.254.0.0 with the prefix 16. What does that mean? For example, I'm a device using Windows OS in local network. I'm trying to connect the DHCP server to get an IP address. So I did not receive any response from the DHCP. In this case, my OS will give me an IP address locally within this range. What we call this automatic private IP addressing, APIBA, automatic private IP address. Now, any computer with an automatic private IP addressing assigned, it will not, or this computer will not be able to connect to any other device in that network. Why? Because all the active devices on that network will belong to different IP range or domain. The local network address 192.168, for example. Also, note that this feature is only available in Windows-based machine. Linux, Mac OS does not use the automatic private IP addressing. So if the device is enabled to communicate the DHCP server, then the server cannot assign IP address for a specific network, and the device in this case will not be able to communicate with any other device within that network. Now, how we can check the IP address assigned to our device on Windows-based computer? We can use ipconfig/all commands or ipconfig command. If we are using a Linux or Mac OS, what we can use instead of ipconfig, we will use ifconfig in this OS. Also, we are talking about here the gateway issues. Simply, no gateway, your device will not be able to communicate with any other device outside of your local network. So gateway for the end device is the closest network device belonging to the same network as an end device that can forward the traffic to other networks. Without a gateway, we cannot communicate with any other device in different networks. So if the device has an incorrect or non-existent default gateway address, it will not be able to communicate with devices in remote network. Similar to IPv4 addressing issue, default gateway can be related to a misconfiguration when we manually configure our gateway, or it can be DHCP problem if automatic assignment is used. Stateful DHCP in this case. Verify that a default gateway in Windows-based computer is correct or not. We need to see what's the IP address of for our device default gateway. We can use ipconfig command as well. On the routers, we can use the command show IP route to list the routing table and verify that the default gateway, which known as a default route here, has been set. Finally, the DNS, domain name service. And you know, main function of the DNS is to map the domain name to an IP address as well. So it's common for users to mistakenly relate the operation of an internet link to the availability of the DNS. Means my DNS server is incorrect, cannot communicate with any website. You will see that you will enter google.com, you will receive an email or a message in your browser that domain name cannot be resolved to IP address. So it's a domain name issue here, not a LAN or a connection problem. So DNS server addresses can be manually or automatically assigned also to any device. Although it's common for companies and organizations to manage their local DNS server. So any reachable DNS server can be used to resolve the names in this case. Some organizations provide a free DNS server. For example, Cisco offers OpenDNS, which provides secure DNS services by filtering phishing and some malware sites. So we can use this IP provided by Cisco as our DNS server. We can use 208.67.222.222, or we can use the other one. Google, for example, providing an open free DNS server as well. So you can Google their DNS IP address. You can use it to resolve the domain name to an IP address. Now, how we can verify also the DNS? Same like the IP gateway, we will use the IP config/all to show or to verify which DNS server is in use by the Windows computer. Also, we can trace troubleshooting the DNS. Is the DNS operate or functional correctly or not? We can use what? NS lookup command. So NS lookup commands is another useful here troubleshooting tools for PCs to check if the DNS server operates or not. With NS lookup, the user can manually place any domain name and monitor if the DNS name will be resolved to an IP address or not. So we can send the query, analyze the response in this case. This is the last part of CCNA1 Introduction to Network. As I have told you, we are going to start, inshallah, from next class with CCNA.